Hello everyone and welcome to the Game Engine programming series where I write the game engine from scratch. In the last video, we finally started working on the game engine itself and the entity and component parts, but our efforts were mainly focused on setting up this little system for our indices, the indices that we will use to refer to our components and entities. I never talked about why I'm not using pointers instead of indices. Maybe I should do that now. As we probably all know, the pointers in C and C++ can become invalid. So for example, if you have a vector and you add an element to it, but there is no space left in the vector for the new element, the vector class will allocate a new region of memory and copy over the data and add the new element to it. So if you had a pointer to any of those elements, then your pointer now is invalid and points to the wrong location in the memory. But if you had an index to one of those elements, that index is still valid, right? So that's why I'm using indices. Indices are not perfect though. They can become invalid as well if you remove an element from within a range of elements in a list or in a vector. For example, if you remove the first element and you had a reference to the second element by index, then your second element is now first element and your index is pointing to the wrong element. But that's not something you're going to do in the entity and component or actually anywhere basically in the engine. I'm going to use what is called a vector or an array with holes. So if you go back to this block from Stingray, they have this drawing of an array, and these gray parts represent the removed elements. And whenever I remove an element, I just leave a hole in there and remember where these holes are. And then whenever I need to add a new element, then I just use these empty spaces to add a new element. And that way, our indices to the locations will always be valid. So this way, the index method that I'm using here, or the indexing method that I'm using here, is better than using pointers. And by the way, we are using 4-byte indices. And on a x64 platform, pointers are 8 bytes. So that's also bigger, like twice as big. A list of pointers would be twice as big as an array of indices, right? So that saves us a lot of space as well. So today I want to continue implementing the interface that we set up last time for the entity and transform components. I'll start with the entity first and then implement these methods for the component as well. Okay, so in our CPP file for the entity, which is now empty, I'll just include the header for the entity. So here I made an anonymous namespace, and that's to make anything that I put in here inaccessible from outside this translation unit. So for example, if I have a function or a variable, these can't be accessed from outside this CPP file. So this is kind of equivalent to have an encapsulation in a class, right? In a private part of a class that you can't access from outside. But anything in this CPP file can access these variables and functions. Another way to do it is to use the static keyword. So this would be the same. But then I'd have to add static keyword to everything that I want to keep private to the CPP file. So that's why I'm using namespace, just to make it easier for me to have private variables and methods in a translation unit. So in here, for example, I just want to remember what components we have. And I would like to remember our generation indices as well. So this would give me an array of generations. I'll explain what I want to do with this in a minute, but first I want to set up something that allows me to switch between implementations of vector. Because at some point I think I'm going to implement my own version of a vector. And I want to be able to switch between the STL version and my own version. So for that, I'm going to create a utility header. And here I'm going to define two pound defines. So for the vector and deque, I know that I'm probably going to have my own implementation at some point. And so with setting this to 1 or 0, then I can switch between my own implementation and the STL's implementation. So what we have here is that I made a vector type in the UTL namespace, and I made a deque type in the UTL namespace. And right now they just are a rename for standard vector and standard deque. But whenever I have my own version, I just set these to 0, like so. And then whenever I have my own, like the template class, for the vector or deque, then this one will be used in the code, right? So I'm going to include this header to common headers. And then going back to the Entity.CPP, of course, I forgot to put back these ones here. So when I, again, re-enable use of STL, vector, and deque, then now I can use it here as well. So I don't have to ever do anything here if I want to switch between the STL vector or my own version. Okay, now I'm ready to implement these two methods that I have here. Actually, 3 methods then that I have here for the entity. Okay, first thing I want to check is if in this information structure there is information about the transform component as well, because every entity has to have a transform component. So if we don't have a transform, return the default value for entity ID. So now if you go back to this ID file that we have, I can see that the default value for an index type, the typed ID, is this ID mask, which is -1. But that's in debug build. Whenever we are in release build, then this typed ID is just a U32. And the default value for that is 0. So now we have potentially a bug because in one build we return -1 and in the release build we return 0. And 0 is a valid index value because our indices start at 0. And that's not good. So what I wanted to do to fix this is to introduce an API for our methods here that actually exposes some functions from their library to the game code, because obviously I'm not going to want the game code to be able to access everything in the internals of the game engine, right? So I want to expose some of the functionality in the engine, like retrieving information about entities, setting some of the properties of the game entities and components. And other than that, everything that's inside the engine is for the engine to use and not to be accessed from the game code. And whenever I have that API, I can also initiate these indices with the right invalid value instead of having these two different values. And that way I can kill two birds with one stone.
Like this.
Well, maybe not like that, but let's see. First of all, I want to have a more descriptive name for this ID mask. I'll call it invalid ID. And for some of these constants, I don't want them to be accessed from outside this header. Well, that's difficult to do because anything that's in a header is in theory accessible by any file that includes this header. But I can make a note by setting these in a different namespace that says, well, it's internal, you're not supposed to use these. Now, as we can see, these aren't accessible, so I have to put internal in front of them. Okay, and here at index, I also want to assert that the index is valid. So the index part of this ID, there is a generation part and the index part. I want to check that that index part is also a valid value. And I see I have something that's not correct here as well. Well, right now it is because we have a generation bits of 8. So the highest value in a generation part is 255. But if we would change this to any other value, then this wouldn't be correct anymore, because then our max value for the generation would change as well. So I'm going to calculate that max value here on the fly. Okay, this shifts 1 by generation bits to the left and then subtracts 1 from it. And that leaves us with the mask that we need, right? So as you can see here, it's now 255, but if I would change this to 10, for example, then it would give me 1023. So that's good. And the last thing I want to do is just to give this the default value of an integer, which is 0, because when we are in the release mode, then it should have the same default value. Otherwise, we'll have two different behaviors depending on our build, which is not good. This is giving me an error because, well, obviously this ID type is an unsigned integer and I'm giving it a negative value. So I have to cast this to an ID type first. And that's basically just doing something like this. Or maybe, well, I can use it like this, but I can also do this. I think that basically comes down to the same thing. We have to go back now to the Entity.CPP file to finish our implementation. But I wasn't done yet solving this problem of default values, because now, although we fixed that here, now all the indices have a default value of 0, I still have to set that to like ID invalid value in every time I want to return an invalid index or ID, right? So in this case, because I don't have a transform component, I want to return an invalid ID. But I don't want to do this every time I need to have an invalid ID, right? I want to return something that has this baked into it, basically. So I was talking about this API that I would expose to the game code. And in there, I want to have classes that do this for me. So if you bear with me for a moment, then it will all become clear in the next couple of minutes. Here, I want to add a folder. And here in the engine API, I put everything that the game code can include to access the game engine. First, include the common headers. Actually, the component headers from the components. And here now we can see that every time I create an instance of this class without a parameter for the constructor, then it will initialize to an invalid ID. And that's exactly what I want. So now I can, here in entity, instead of returning an ID, I'll return an entity. And then here I can just do this, right? Entity, and then it will return an entity with an ID of invalid ID. But first, I have to include this header again to the common components common. As you can see, this makes it like a circular header dependency. So I'm including this components common in game entity, and components common includes it here. And that's not something I'm proud of, but sometimes we have to do it in C++ because of C++ headers. And that's why this pragma once has been invented as well. So this solves the problem of this cyclicness that once we are here, then this header won't again be loaded in game entity header, right? And since now we have this game entity that will be included in everything in components, I can now also move this part, the definition for entity ID, to game entity itself. I think that makes it a bit more concise. And then I can remove it from here. So now it recognizes this entity. And okay, I can go ahead and try and implement this further. One other problem that we have is that if we look at this drawing, this element that is empty, if we remove elements and add elements to the same location all the time, then this generation part will wrap around very quickly, right? Because if you write to this location 255 times, then it will wrap around. And that would lead to bugs quicker than when we would spread our writes to different locations. So that's why I'm going to have a deque here. And then I'll have a minimum amount of removed elements before I start writing back to the remove elements. So here in ID, I'll have an extra constant. So this tells me that after 1024 removal of elements in the array, I start writing back to those available slots. If this size is greater than 1024, then I'll reuse my slots, and otherwise I'll create new slots at the end of the array. I changed the parameter type of these functions as well, here in the header and in the CPP, to accept the entity class that we just created here. So now if I have enough free slots available in the array, I pick the first one and check if it is indeed one of those dead entities, and remove it from the free IDs because I'm going to use it. I'll increase its generation. For example, I have this generation 2, and then the ID itself is like 5. Now I'm reusing slot 5 from the array. And because I'm reusing it, I'm increasing its generation to 3. And then I will be returning this ID, but I still have to remember the generations for this particular slot for me to later be able to compare them to see if the ID that I got is actually alive. So if I don't yet have enough free slots to reuse, I'll just add a new element at the end of my list of entities, right? So here I determined what entity ID I need to use. Either I reuse an existing free slot in my array, or I add a new one at the end of the array. And then I can put that ID in the new entity and return it. To remove an entity, I just push back the ID for that slot that I'm removing back to these free IDs. Now I need to be able to get the ID from this entity class. So I'm going to have the method that gives me back the ID. And while I am here, I also add a method for checking the validity of this ID. So that's it. I just add the ID that became free now to the back of the free ID so I can reuse them later. Now I have to implement the isAlive function. In this function, I just acquire the generation and the index part of the ID that we have, of the entity. And well, I check if the entity is valid. And then I get its entity ID, its index, and then check if the index is within the length of our generations, because the length of these generations is an indication of how many slots we have for entities to exist in. So basically the maximum number of entities that we have until this point. And then I return whether the generation for this particular entity equals the generation of the slot that we have for that entity. And if that's the case, then this entity is alive. If the generations differ, then this means that the entity has been removed and another entity has been in its place. But as we will see in a minute, this is not enough because, well, if we remove an entity and don't write back to that slot again, then this generation will still be equal, right? So I'll have another condition that makes this more precise. And that's when we add the transform component. So for now, let's see if we have any errors. Okay, this can't be a constant expression. It's just like so. Well, actually, it can be a constant expression, but then we have to go back here in the ID and change these functions to constant expressions as well. I'm getting a warning, which is rather lengthy, but it's about the exceptions that we disabled. Whenever we are using the STL classes like vector or deque, they'll use C++ exceptions. And then while we can build our project, it will give us this warning, which is annoying. So I'll just turn off this warning so I don't get this warning anymore. And that I can do in common headers for the entire engine. So here you can see the number of this exception warning. It's 4530, and I can put it here to disable it. Now, if I compile again, I won't get that warning anymore. Now, before I implement these methods, I want to make the engine API header for it first, like we did for the game entity. So now I will add another header. Okay, we don't have transform ID defined here. And I defined the transform ID here in the transform header. So again, I'll move that to its component. And again, like I did for the game entity, I'll have 4 methods to construct the class and to get the ID and to check if it's valid. Okay, now I have a class for this component as well. So for all component types that we will have, this is kind of the structure that I'm going to use. So I have a namespace for that component, and there is a class in that namespace with the component information in it. Now, going back to the entity, I can have an array of transform components. And of course, I need to include the transform header. And since it still doesn't recognize this component, I have to include this transform component here as well. Okay, now we can create a transform component whenever we create a game entity, because all game entities have a transform component. Okay, so now I have to change the signatures for these functions in the transform header. Now this will return a transform component. The idea here is that whenever we add a new entity to the end of the array of entities, I add a default component to the end of this transforms array as well. And well, I could also do like something like transforms and then resize to the generation size. But this will allocate just enough memory to fit one more element in there. And when we use mplaceback, then the effector will reserve like 1.5 times the amount of memory that is already reserved. So using this mplaceback will result in less memory reallocations. So that's why I'm using mPlaceBack. So if this create transform function would return an invalid transform component because somehow it failed somewhere, then I can check that here to see if it's invalid. And if that's the case, then I just return a default entity class, which contains also an invalid index. So the caller of this function can check if the entity is valid as well. So that's the way we can fail if something goes wrong with creating a game entity. And then in remove game entity, I have to remove the transforms as well. Whenever I remove an entity, I put a default component in that slot as well. So this slot in transforms will now contain a transform component which is invalid, which has an invalid index or invalid ID. And then when I check if the entity is alive, I can also check if its transform is also invalid, and that means that this entity is really dead. So this entity is only alive when the generation of its ID equals the generation of that slot, and if its transform is valid. Otherwise, it's something wrong with it or it's already removed. Okay, now I can, here in game entity, the entity class, add a method to get its transform. So remember these components from the viewpoint of a data-oriented design. It's just a 32-bit integer, right? Nothing more, nothing less, basically. So there is no need to go and have a reference or doing it like const or whatever. It's just a copy of an unsigned 32-bit integer. And then I can implement this. We don't have a CPP file for these headers. The methods that are not inlined here, I can implement in the corresponding private component translation unit. So for example, to implement this method, I can go here. So here I check if I, as this entity, have a valid ID, and then get the index to it and check if the generations are the same, and then return the transform for this index. I think I can condense this to, like, I can check if I am alive, right? So I think I can do this. So this will do those checks for me. It will check if the generations agree and the transform is valid. And if that's the case, I can return this transform, right? Actually, this should be the case already. So I'll just assert this. and then we are done. Okay, now I'm going to implement the part for the transform component. So add a translation unit for it, like a CPP file. I'm having an error here. Let's see what's going wrong. It says that there is no app. Oh, I see. It's a copy-paste error that I just made. If I go back here, there is this explicit keyword that's not correct. So I have to remove it and remove that in transform as well. And that should give me a correct default constructor for this. I need to have arrays of some type for position, rotation, and scale. And well, we don't have a math library yet with 3-dimensional vectors or 4D vectors for rotation or quaternions, etc. And for now, I'm going to use the DirectX math library, but I don't want to mix Windows-specific stuff with the rest of the engine. So what I'm going to do is in the command header, just check if we are in a Windows platform. If that's the case, I include the math library from DirectX. So now, for example, I could do something like DirectX and then vector, I think it's XM float 3. So this is a 3D vector. It's just 3 floating points, floating point values. But I don't want to use that here because it would make this whole module depending on DirectX library. So I'm going to rename these in another utility header that I am going to create. Let's see if I can get a value for pi from the calculator. Well, of course, I can Google it as well, but well, yeah, here it is. Why is this giving me an error? It's just a number, right? I guess that's just Visual Studio kind of being confused. This is for our floating point comparison. So I can have a comparison with a precision of 1 in 100,000. Now I'm going to just define all the vector types that I want to have for use in the math library. I think I need to restart Visual Studio to get rid of these errors. I think it's confused and just about to crash, probably. Okay, now I have renamed all the types that I want to use from this math library of DirectX. And let's see if I can put this back, the value for pi. I copied this value from the calculator and it's using some kind of weird Unicode encoding. So let me see if I type it here. Okay, I managed to get the value for pi with a normal encoding. And now I can use these types in the transform component. Of course, I have to include the math header in the common headers as well. I made a typo here. I have to change it to position. And now I can implement the creation and remove functions for the transform component. Unlike for the entity, here I had to keep track of generations and free IDs. I know that the list of transform components will be in sync with the list of entities because every entity has a transform component. So I don't need to do all this because it's done for me basically in a game entity module. For other kind of components that we can remove and add to an entity, I will be keeping track of generations again because, well, for example, for a script component, not all entities have a script component. So we will have to check if these generations for the script component will be okay. But for transform, I don't have to do that. And that makes it a bit simpler to add a transform component and remove it from these arrays. So here, if the component that we are trying to add is within the length of the array in which we put our entities, then, well, we just overwrite that slot with the new values that we get. That means that we are filling one of those holes in the array, right? So we can reuse one of these elements. But if we are adding a new entity to the end of the array, well, obviously the index of the entity that we are trying to add should be the size of positions or, well, rotations, or the size of these three arrays, because we are adding one more element to the end of them. And the new ID for this component is just the size of these arrays. You should note that these arrays have the same length, of course. So I can take any of them and the length of any of them to generate an ID from. So this will give me a new component, ID actually. And for removing a transform, I don't have to do anything because I'll reuse all of the removed elements anyway. I just assert that this component is valid. And one last thing I want to do for today is just to introduce a couple of methods to get position and rotation and scale. And again, the same as I did for the game entity, I just implement these methods in the translation unit for transform. And this kind of finishes the implementation of the entity and transform components. For so far, we have components to add in the entities. Next time, I would like to write a test program to test everything that we just did. So we can check if we can add entities and remove them, and if this generation and index system works properly. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus, there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering!